Okay, fantastic. All right, hello everyone. Uh, Sorry, let me just make sure I have this so I can click. But yeah, hello everyone and welcome. I'm glad you can make it. But yeah, so today we're going to be introducing QED. So we call ourselves the world's first ZK 2.0 blockchain. We're horizontally scalable and verifiably secure layer 2. So we're essentially built to solve some of the main, I guess, pain points for blockchain adoption that we currently see. One being like the state of Web3 development tools and some of the rest of the ecosystem compared to some of the Web2 languages. Also, with regards to scalability, like right now we've seen L1s with serial state models max out at around 10,000 TPS. There's a CPU bottleneck, and as we see with Moore's law, like we're probably not going to be getting much faster. And then also on the UX side, like Web3 right now isn't very competitive with Web2, just in terms of like some of these very conversion-sensitive experiences where whenever you interact with blockchain, you have to pay and wait for a transaction to be processed. So yeah, if we look at the current ZK VMs right now, they really don't solve any of these problems. They have the same like developer experience quality, if not worse. Like, while Cairo may be a great language as well as Move, the amount of tooling for the ecosystems is very, very small. And the developer community is essentially like a three-figure, under 1,000 total developers compared to a lot of the other language ecosystems. So really, like, if we want mass adoption of users, it's probably going to be necessary for us to also have mass adoption of the developer community at large. And then on the like TPS side, I think StarkNet recently hit 30 TPS. So that's great, but it's not really making any headway towards the ultimate sort of scaling dream of blockchain and the capabilities of ZK. And then again, on the user experience side, we have the same sort of bungled user experience that often kills conversion. So QED is quite a unique solution. So we actually allow developers to write ZK smart contracts in JavaScript and Python. And then we compile each of these contracts to a Merkle tree whose leaves is the verifier data of each of the ZK circuits which are allowed to operate on that contract state tree. And then in addition, we're horizontally scalable, so we don't have a single state tree for each contract. We have a state tree for each contract for each user. So because of that, we can guarantee that there's no race conditions when you're proving transactions in a block in parallel, since users can read from each other's states at the end of the previous block without being able to write to each other's state tree. So as long as the user modifications to their own contract state trees are done serially, you can parallelize like the sort of, so we have a recursive chain of proofs. So the end proof in a local chain of proofs which amount to some transactions. So essentially, users can prove a bunch of transactions locally, submit a end proof which has recursively verified all of the transaction proofs that they've made, submit that to chain, and then the actual process of building a block out of those end proofs, like the work that needs to be done by the network, is fully parallelizable because we just have a structure of proofs or of zero-knowledge circuits. We actually call it parth, or parallel ascending tree hierarchy. Recursive tree hierarchy. Yeah, so we mirror the state of like a large Merkle tree, and the end result is, of course, with Merkle trees, we can build them in parallel. Like, for instance, we can prove that certain users updated their trees up to a certain Merkle cap, and we can do that like in parallel with another part of the tree, and so on and so forth. And we arrive at a block time of around O of log 2 of n, where n is the number of users that are submitting transactions within a block. So not only is the block time not contingent on the number of transactions processed in the block, but also we have like very, very, very efficient block times, just because all of log 2 is pretty good. So like, just for some perspective, like let's say 4 billion users submitted transactions in a block, you'd be looking at something like 32 times the amount of time it takes to prove a recursive proof that verifies, in our case, like a 2-to-1. So take two proofs, recursively verify them, and then also verify the associated Merkle proofs. Oh yeah, and then also, as I mentioned, like we prove every transaction, so we're not like optimistic. We actually are quite ideologically opposed to this kind of idea. Like, we still believe that all transactions should be validated, and obviously, if we can generate a single succinct block proof of all transactions, then we can make that happen without sacrificing scalability. But yeah, so we're super developer friendly. As I mentioned, we support vanilla JavaScript and Python. So we've really taken a lot of measures to make it as compatible as possible with vanilla JavaScript. Obviously we can't have non-deterministic features of JavaScript in a ZK circuit building platform. Like, we don't have math.random, right? We don't have some IO functions, some string building functions, but all of the core language features that JavaScript developers know and love, as well as Python, Python like map operators and lambdas and so on and so forth, we all have support. So because we support this sort of unmodified vanilla JavaScript, we're able to inherit all of the tooling that their million-plus developer ecosystem has built. So, even if we really try to build out our Solidity, let's say, tooling infrastructure, it's very hard to compete with the number of man-hours that have already been invested in all of these mature languages. So, yeah, our value proposition to developers is more just blockchain development with zero learning curve. So I think this also makes us we're a little bit different than other projects in our approach to this. Like, we're not trying to cannibalize existing Solidity developers, and we encourage and love Ethereum ecosystem projects and ZK VMs and so on and so forth. We're just trying to bring more developers into the ecosystem that previously, I guess, weren't able to benefit from blockchain. So we already have a full IDE, and we have an internal testnet. We'll be launching testnet in a few months. But yeah, this is just an example of some of the tooling that we have. We have a visual debugger. This is something that Remix has lacked, a good visual debugger for a long time. It has a debugger, but it kind of doesn't work. Yeah. But yeah, we have we try to make everything as nice as possible. It's a lot easier to debug our JavaScript contracts than any other ZK VM's contracts. And yeah, we have right now about 20 devs who are working purely on just building out developer tools, UX improvements, making it as easy as possible for non-blockchain folks to build on QED. One of the advantages of using JavaScript is that LLMs are very good at writing JavaScript in Python, because a lot of their corpus, a lot of their training data from GitHub was JavaScript in Python, because it makes up such a large amount of just the data on the internet that is related to code. So it's very good. We have integrations with GPT-4 and Claude 2. We're leaning towards Claude 2 just because it has a larger context. So the larger the context is, the more sort of best practices we can tell the LLM before we actually ask for user responses. But the main takeaway is you can essentially just write a contract in Markdown with each function sort of saying what you want it to be, and then it will automatically generate the ABI and the contract code for you. And then as we see nowadays, everyone is getting their contracts evaluated by third-party security firms or audited. So I think this actually can be a viable solution as long as there's a third-party auditor, making sure that there are no implementation bugs and so on and so forth. But generally, people are doing that anyways. So for some contracts, this may be quite an attractive solution. But yeah, I can go over here. I don't think we have much time. But yeah, so our flow is quite simple. You just compile your contract. You recursively prove all of the transactions that you want to make locally. So, whenever you are sending a transaction on another blockchain, generally the user flow has to be interrupted, and they have to sign and pay a gas fee. But with us, essentially the dApp can decide when that's appropriate. We also have some mechanisms for doing delegations so that you can get sort of sub-finality for third-party applications. We do that by saying okay, for the next 30 minutes, any transactions that I send must be signed by myself and another third party. So we can guarantee, to dApps that if you send your proof chain to them, or one of the end caps of your proof chain to a third party that's allowed to submit for you, they know that you're not going to submit conflicting transactions within that period. so that they don't have to actually pay the gas fee, and they can have like game logic or other sort of mission critical logic run under the assumption that these transactions have been executed. And yeah, so every block proof of ours proves every transaction in the block. So we have, as I mentioned, a recursive tree hierarchy of proofs, and we have a single block proof which proves every transaction in the block, as well as recursively verifying the previous block proof. So therefore, every block proof by induction proves every transaction that has been executed in the chain's history. We also have in that proof in the public inputs the start and end state roots. So you have a single state root that has like all of the data of the chain. If you want to, let's say on L1, grab some data, or maybe I'm like bridging tokens from L2 to L1, just provide a Merkle proof and you'll be good to go. So yeah, we end-to-end prove everything, even if there's no 51% attack with QED, because you just, you can't like generate a false proof. But yeah, so I don't think we have much time, 2 minutes. Oh, okay, great. Yeah, so just to like kind of look at the reason why, because I know it's like quite bold to say like, oh, we are ZK 2.0, right? Like a lot of people like to give themselves generational boosts, but we believe it's warranted, just because usually like major version increases happen when you get benefits or positives without any trade-offs. So like, let's say a laptop from 10 years ago. The processor was slower and it had less cores or less hardware threads, right? Is there any trade-off for having faster laptops now? No, right? It's not like something else had to get worse for something else to get better, and that's why we increment the version of the processor, right? So like as I mentioned, because we have because we take the step of isolating the user's state, or the user's state that can be writable by the user within a given transaction, we get the benefit of just being able to execute all the transactions in parallel. Because we eliminate any chance of a race condition. So we have like hard guarantees against race conditions. And then also, because we support JavaScript and Python for normal Web 2 developers, we support all of the tools that they already are used to working with out of the box. So yeah, and like as I mentioned, we prove transactions in the background, and users are only prompted when the dApp wants to submit the transactions to chain. So as like a dApp developer, much like a Web 2 or a games developer, you can decide when in your user flow it's appropriate to like ask the user to pay for something or to interrupt them at a time when you think that it has the least risk to your like conversion. Because if at the very beginning you ask them to do some of these things, the user just leaves the application, right? Yeah, we have our white paper will be coming out quite soon. We have some other talks at ZK Day if anyone else is coming. Yeah, we have some information on our Twitter about our account abstraction. Our censorship resistance is also quite good. We'll have that more information in the white paper. It has a little bit to do with our tokenomics and the proofing structure. But yeah. So maybe I could just show everyone like a quick demo. So because we can prove transactions in parallel, our block times can be very, very fast, even if we have like hundreds of thousands, if not millions, or even billions of users submitting transactions at a time. So here we have like on OpenSea a dynamic NFT's states updating in real time. So what's happening here is we're proving locally that I hit someone, right? And then after that, we're submitting our proof to the chain. It's aggregating the global state. And then on OpenSea, we have an HTML application that's essentially just hitting our API, requesting the latest proof, the latest block proof, as well as a Merkle proof of the storage slot, which holds the counter for this sword. And because we store these HTML viewers on immutable storage, you're guaranteed that whatever you see on OpenSea is the actual value of the state on the blockchain, and that it has correctly verified that the state that you're seeing is correct. So this is important if the metadata of the dynamic NFT affects the value of the NFT, because of course, like if it's a level 10 or a level 1,000, warrior or whatever, this may have a great impact on like the price of this item. So yeah, metadata matters. But Yeah, we also have some solutions for privacy and AI. So the great thing about having parallelizable state is that you can prove transactions locally. And that means that you can do computations with sensitive user data and be guaranteed that the sensitive user data never has to leave the user's device. So you don't need FHE, which is going to be very, very expensive to do in ZKP. Like ZKP, like non-native operations are already very, very expensive. It takes a long time to prove, and it gets even worse with FHE. But you know, if you prove locally, you avoid that entirely. And yeah, so like we can do like AI inference. We made a TensorFlow. We have Keras support for it coming very soon. It just TensorFlow Lite was a little bit easier to port. But yeah, we have some like model hierarchies that essentially like we can retrain existing pre-trained models to be hierarchical so that you have like descending smaller and smaller and smaller circuits, which is very important for like parallelizing them if you want to do ZKML. But yeah, so there's a paper called SplitNet that you guys can check out if you're interested in that. But yeah, so we want to have like very easy sort of drag and drop pre-trained models into our IDE and be able to do AI inference on chain. So yeah, we have some great partners already. You know, we'd love to bring on more, and yeah, we just recently signed Universal, so we're very excited about that. But yeah, if anyone has any questions, you know, please let me know. I'll be walking around, and yeah, I'm curious. I think we have a little bit of time. Does anyone have any questions?
Yes, questions? Okay, thank you.
Oh yeah, maybe just really quickly a bit about myself. So I come from like the video game security industry. So I was a member of Xbox Underground, which is like a hacking collective when I was naive and in my youth. I also built ModP, which is the world's largest Minecraft Pocket Edition, like mobile edition of Minecraft modding platform. Had over 150,000 developers, 20 million installs, and then. You know, also as our advisor, we have Scott that just joined us, one of the co-founders of Gitcoin. So, you know, very happy to have, you know, some titans of the Ethereum open source ecosystem on board as well. But yeah, please.
Thank you, Garda. Just a quick question. Could you tell us a bit more about the? You talked about how you had a decentralized network to submit to prove transactions. Is it decentralized in a point where every user could, on its own, submit a proof?
Yes.
What's the economic model behind it?
So yes, this is very key as well. So the requirements to actually participate in decentralized proving are very, very low in terms of both hardware and like, I guess like you don't have to have tokens staked for you to participate in this process. And also we allow for data availability nodes, let's say nodes that are, you know, incentivizing people to, or rather that are like storing the global state and providing information required for provers to do their job. They can provide data encapsulated within a proof such that if you then use their data to like essentially generate a decentralized mining proof and contribute to the network, the reward fee is split between the data availability node and the user. And with a few of those transactions, you actually have enough tokens rewarded so that you don't have to pay a gas fee. So as a user, if I just do like about 500 milliseconds of work, I don't need to pay gas to submit transactions. So if you want to onboard users without like having them have to go to like a centralized exchange, like Binance or some of the other evil folks, and purchase tokens and go through KYC, you could just, you know, give them 500 milliseconds of proving time, and that will be sufficient to submit one transaction. And this is also one of the great benefits of like having you know, having like constant essentially work that needs to be done by the network to process transactions, because you're literally like the only really hard work being done by the network is just taking a bunch of proofs and verifying them in higher order or in a recursive proof. So yeah, great question. Any other questions? Okay, well, thank you guys for bearing with me. I know our talk wasn't scheduled, so I'm very appreciative to those who sat and like stood by. I think there was a scheduling glitch, so we didn't have many in attendance, but thank you for listening to me talk. And yeah, I'll be meandering around. Again, I'll be at ZK Day, oh yeah, this is just some random gobbledygook. Yeah, you can check us out. Here's the website if you guys are interested. I don't think we have it in the deck, so I apologize. But yeah, we'll be kind of hanging out. Thank you guys for your time. Yeah, that's it.
Thank you.